Şeyi başlatacağım. Berkay. Berkay. Başlatacak mıyım? Hayır.
Deniyorlar mı?
Gidiyor mu diye şey yaptım ya, bilmiyorum. Hakan Hoca. Tamam sanırım hocam.
Bir mikrofon deneyebilir misiniz rica etsek?
Geliyor ses.
Tamam.
Okay. Good morning, everybody. Welcome to the morning session of this Congress. My name is Hakan Gür. I'm from Middle East Technical University, Metallurgical and Materials Engineering Department. Today we have 4 invited speakers. And the first speaker is Mete Bakır. Please.
Good morning, everyone. Thanks for inviting me to this meeting here. My name is Mete Bakır, and I'm here with 2 heads today. I'm a materials engineering manager in Turkish Aerospace. So we take care of all the materials in aerospace, like aerostructures. And also I'm an assistant professor in mechanical engineering at ANKARA University. So I'll be representing the company as well as representing the university, show some work on what we do in the company and show some work on our research. So I don't know if you are familiar with the materials engineering in Turkish Aerospace. I can ask really how many of you ever heard the materials engineering in Turkish Aerospace? Okay, some people, some of work there. So it is a well-rooted department with more than 30+ years of experience in material science, starting with the F-16 program And then we are kind of moving towards the TFX role. So our core competencies include, can I see like ekonomi alma imkanı olur mu? Böyle bak, nasıl şu şekilde. Aynı şekilde.
Onu orada ekran çalışmıyor tabii.
Çalışmıyor mu? So I need to like.
Ha, bu arada gezerek mikrofon verebiliriz hocam. İsterseniz.
Daha güzel olur. Thank you. So our competencies include metal alloys. So we use conventional and next generation metal alloys. We work with assembly technologies, very comprehensive departments, including like assembly technologies, mechanical valve physics. Is there like new trend in different sectors? So in industry, with metals and plastic.
Bir tane daha geliyor. For surface technologies, we do corrosion prevention things and sealants, etc. Special processes, one of like the main or major core competencies is the special process technologies. The materials is one thing, and the processes are other things that include the manufacturing processes, the surface treatment processes, the way that we make sure the material goes onto an aircraft. The calibration, metrology, and test and characterization. So we have an extensive and almost accredited lab on material and process testing. So I'm introducing that part as well. So as I said, as the materials engineering in Turkish airspace, we have a cumulative more than 30 plus years of experience. We have material scientists, engineers, mechanical engineers, and electronics engineers with masters and PhDs in top universities from Turkey, and we have some graduates from international colleges. I don't like this thing that facilities. So to be strong in what you do, you have to have a good like infrastructure, including the team, including the equipment, etc. So we are planning to move to a new facility. Our team is working like diligently on that part as well. So it'll be the top materials research and characterization lab located in our headquarters in Ankara, Kazan. And we will get the international accreditations as well. So we are looking for new graduates and researchers to come there and work with us towards like the new technologies. So the department is, as I said, a well-rooted department. We have a lot of accomplishments. So for example, like within the span of like 30 years, we have worked on 70 plus international and national programs, including F-16 and some Airbus and Boeing programs. And very recently, the TFX and Hughes, the domestic programs. So we qualify materials, we qualify processes. Qualification means we make sure that by engineering terms, that material with a specific process is applicable for airspace, which is way different than you can imagine with the automotive sector or like other conventional ways. So we have accumulated a lot of experience through these programs, and we are helping our indigenous programs right now. And we do a lot of testing. So it is a really strong, and I would say excellent testing facility for material characterization, including mechanical testing, physical chemical testing, non-destructive testing, and And we are recently getting some electromagnetic characterization systems as well. And we have international partners and collaborators from all over the world, including the major suppliers in the sector. So the company is mainly located in Ankara. Some of you may know Kahramanmaraş, in the total area of like 4 million meters square. Indoor space is around like 660. So regarding the material technologies, we have recently built this Turkish-based composite manufacturing facility, which is the largest in Turkey for composite manufacturing and the fourth largest in the world. So it's a major accomplishment for our company and for Turkey as well. So we are hoping to get a lot of things done within this facility. And the target is to reach up to 2% of world composite manufacturing in the world. So it's like a great number. And if you get up there, it'll be good for the economy and the inflation problems as well. So on that side, that's the big picture. On a smaller scale, we are getting this material process and calibration laboratory, as I mentioned, the top testing facility in Turkey. So we are hoping to employ 200 engineers there. So right now we are about like 100 plus engineers. So we are hoping to get more. And I'm hoping that we will get some people from there with us. So I have a short video demonstrating our composite manufacturing facility. That other building is under construction right now, so I don't have anything to show yet, but I'm hoping to get there soon. Okay. I don't know how to on the video though. Bu video çalıştırma imkanınız var mı? I don't want to spend too much time on the company's product portfolio, but it's important for us to highlight that the materials that we deal with within our department goes onto these products, including the aircraft, helicopters, UAVs, space, and commercial programs. So whatever we do, including composites, metals, some sealants, joining, and surface technologies, they directly go into this program. So if you have a chance to work within like our department, you will have an opportunity to see like what the designs are, what materials they like utilize on their like airframes. So it's a great opportunity for engineers and for researchers as well. So our kind of, I would say the most important program is like the TFX, right? So let's talk about the materials. I just wanted to start with the bigger picture, and then we kind of boil down what we do with the materials on an aircraft program. So the major and I would say the most critical part is structural materials, which includes metals like titanium and aluminum alloys and steels as well, and polymer composites and the process qualification. So we use conventional materials for these applications, and we are in the process of getting functional and advanced materials as well. So I'm gonna be like speaking some details of course. So after the structural materials, we have advanced materials. Let's call that way. So advanced materials is kind of like hype in the like literature or like in the business lexicon, which include the functional materials, not only structural purposes. For example, the temperature, the chemistry, or the environment could be the factors that may affect the overall performance of a material. So that's why we need some advanced materials as listed here. Assembly and joining technologies is the next title. It's not only enough to get the material and the manufacturing process done. So you have to have a system or way to get the structures together. So we have an expertise or branch of expertise in assembly and joining technologies, in which we mainly deal with the surface preparation technologies, how to prepare a composite and metal surface for coating or for chemical processes, whatever that purpose is. And we have advanced assembly technologies. It is not like rivets or not and bolts. So we have some like robotic, some like advanced assembly technologies in there as well. Recently, we embarked on a new journey of getting new materials and new structures, which we haven't done before, and neither country did. So the canopy is one of them. In the past, this is like the overall top curved, like glass-like material is called canopy, which is good for transparency. And we haven't manufactured or designed this canopy in Turkey before. And right now, we are developing or I would say accumulating some expertise on the material characterization, processing, etc. of this material. There's the lamination problem, it's a very big problem, right? So since we haven't done this before, we are learning how to do that, and we need your help from professors, our students, our researchers to generate an ecosystem on this. Radon is the other topic that we are kind of like channeling ourselves right now. So radon is the tip of the aircraft, which could be compatible with antenna, electromagnetic waves, and should be good enough for sturdy enough for mechanical applications as well. So it's way beyond what we have done before in terms of an aircraft structure. So it's a complex problem or multidisciplinary problem, including the material science, mechanical engineering, electromagnetics, and some production issues as well. That's one thing, and we are learning. Additive manufacturing. A lot of people getting into this field, and we are doing plastics and composites, not yet in metals. And non-destructive testing, Hakan Hocam'ın konusu, Ferhat bizimle birlikte zaten, and artificial intelligence. So, do you have any questions? I just want to like the different aspects. So, speaking of materials, do you have any questions right now to ask?
Are you going to produce acrylics and polycarbonate?
So,
Or are you going to buy it from?
so we have some local suppliers that are going to manufacture for us. And then we are going to shape.
Shaping.
Yes. So let's go to the research right now. So we are working on an international collaboration issues with the universities from United States and as well as universities from Turkey. One of the example is the fire retardant composites. We have a direct collaboration with Wichita State University, and we have very well regarded and like him very much, Professor Ramazan Asmatulu. And there's the lab of NIR, National Institute for Aerospace Research in Wichita, Kansas. With them, we develop fire retardant composites for civilian applications, like the Gökbek program, and for TFX program as well, for specifically high temperature regions. I think this program has been a year that we've been working on with them, with the State University and NIR. And we got like really good results, which are recently presented in a conference in the United States. We basically get the main formula or the representation of a fire retardant composite, how that should look like, and what material properties and performance criteria it should include to like the end of this program. So it's a good accomplishment for us, because in the past we didn't have that much of an experience in high temperature or fire retardant materials. The second example is with the University of Illinois, specifically NCSA National Center for Supercomputing Applications. With them, we have developed a tool, machine learning algorithm, to predict the material properties without doing any testing. Not any testing, like 70% less testing, with 95% accuracy. So as I explained, like just before, in materials engineering department, it's one of our like strong assets that we do testing. But the qualification and testing of a material is a long and extensive process, and it takes time, money, and human effort. So to be in line with the recent technologies, kind of like catch the train on this one, be on the right train, we developed a tool for specific metal testing that can predict the material property without doing much of an extensive testing, by reducing 77% the overall test load and providing 95% accuracy. So it was a good overall tool, and we are hoping to use to like in our programs. So we can like I'm just putting the highlights. Let me call it like put it that way. So if you have like further questions after the presentation, we can discuss, and we have experts that they can provide further information. So layer composites. So I have a couple slides. So I said like I'm a faculty at a university, so I do work with some students as well. So with them, we did some research on materials. This specific example goes to the layer composites. I don't know if feel like you ever heard of this layer composite. It's a metal polymer composite with like different lamination sequences. It can provide the lightweightness and overall structural performance with respect to composites and mostly the metals that are currently used on an aircraft. So in one project, I think it's going to say competition right now and grad students. So we investigated the ballistic performance of layer composites. So we got some help from Mustafa Given in Izmir Institute of Technology. So we kind of like shot some layer composites with high velocity bullets up to like 100 meter per second. And then through correlation with the mechanic, like the overall physical testing and simulation, we can predict the overall performance of layer composites, which is a good aerospace qualified material. To supplement our research, we did some CT images to see how these like bullets go through the material, which can be stopped there. For example, if the material is strong enough, it'll stop the bullet within itself. Overall, like the bullet went through the high velocity And then we had a chance to like capture really nice images, CT images and CT scan images. So the overall, the result of the work is to get the ballistic limit for glare composites through finite element analysis and experimental studies. So we very much like the glare. And then since we have done some like high velocity research, let's do some low velocity research. So we had a nice equipment of like operating back test or tester in our lab at the space. And we took the same material and impacted the material with a certain velocity, which is way lower than what we have done with the ballistic material. And we wanted to understand how the low velocity impacts this kind of like overall effective glare composite. For civilian or mostly military applications, we don't want to like deal with the ballistic issues, but mostly the low velocity impact issues. You can have like a bird strike sometimes. You can have like some debris on like the highway that the aircraft is like rolling on. That way, you need to sometimes repair the materials in real life applications. So in that case, we want to like understand the low velocity impact properties with respect to different temperatures, for example, 90 degrees C, and did some microstructural analysis as well. So this work is also going to a publication with our students from ANKARA. Çalışma galiba da sonraki slaytı görebilir miyiz? Hocam.
Kameranın olduğu yere
Evet. Sonraki slayta geçebiliriz. Hocam çok öfkelenmedim ya.
tekrar deneyebilir misin? Bu tarafa doğru tutarsan.
Alt kalite değil mi?
Bilgisayardan da geçebilirsiniz. Maybe it's a sign that I need to spend a little time like this. So our purpose is to have this material on Hürjet and Hürjet programs. So our people like design, engineers like it very much to replace aluminum always like the skin surfaces. Another recent journey on the materials that we are hoping to understand and learn electromagnetic properties of materials for the stealth applications. So as you may know, or now know, that the 5th generation aircraft like the KFX program should be invisible or almost invisible to ground systems, antennas, as well as the aircraft and like air in operation or in the war theater. So we, as a material scientist or researcher or engineer, whatever you may want to call it, we want to make sure that our program aircraft is invisible to those systems. So in that case, we are dealing with radio frequency materials, RF materials, as we call them, and the infrared materials, IR materials. So the technology like globally is very demanding and we don't have that much of knowledge like accumulated in this country. So we are kind of embarked on this journey and learning by ourselves, doing trial and errors. The one thing that you can make sure that the RF and IR properties is good enough for aircraft is using a coating or a paint, if you want to call it. So you can put it there, the radio frequencies may reflect or go through the material and then you can overall evaluate the performance of the aircraft. So this is, I will call it an technology, as technology. Right now we are getting to understand the meta materials.
So when I was in the States doing my PhD there, I've seen a lot of students, professors, researchers getting into this like metamaterial issues. But this is the first time for me and for our engineers as well there to see the applications of metamaterials for the electromagnetic invisibility issues. We have done some initial tests and we are getting there. It's a long journey though, but we are getting there and we are hoping to have metamaterials. And the second part is the FSS structures, selective structures. So we are designing them. We are doing simulation analysis. We are producing them there, and we are testing these structures. These are the next generation electromagnetic surfaces that we are hoping or planning on getting on aircraft, mostly the theory. And the last example, I believe, for this low observability issue is the IR materials. So you can think of an aircraft flying up in the air. So through aerodynamic like friction, the temperature can go up on the surface. Although you can put these electromagnetic materials to prevent or protect the structure from like the ground and air systems, the heating is kind of defy the purpose. So we want to put this IR material embedded within like this overall the laminate structure coating to make sure that the heating is not a kind of bottleneck in this process or in this like system. So we are also working on the IR materials as well. So I cannot like show results because it's like classified information. I'm just like providing overall information to show you that we have like a complex problem set in materials engineering. Oh, we have some data. Okay, this work was done by one of my undergrad students in Ankara University. This is not an aircraft material. This is one of the glass epoxy composites and 3D printed plastics. We wanted to understand the overall electromagnetic response of a certain plastic, I believe, which was EBS right there. With respect to different temperatures and different frequencies, we understood that the dielectric properties, which is the way to understand how the electromagnetic wave can go through a material, is changing. So as we have spoken of like the temperature effect, the iron materials, so we are hoping to understand that effect as well. And we have simulation tools to predict this material property. It's not only the experimental analysis, also the simulation can help us and guide us towards understanding this complex element. Couple slides there. Okay, can we go? Okay. Okay, I think it's the final slide. Yes, we got there. So if you have further questions, you can follow up with me after the presentation, and I can like catch you with some bright people that can answer your questions. And I want to conclude with this final statement that we are building the nation's top material process and calibration laboratory in Turkish airspace. Ersin Hoca is leading that effort. And we will have capacity and capability for mechanical testing, polymer characterization, chemical analysis, electromagnetics and optics, environmental testing, microstructure and NDT calibration topics. It will be international accreditation from ISO and NetCap principles.
Hep daha iyi.
I would love to
Altyapı metrosu. Gelirken de yine bu aynı otobüs buraya getiriyor. Dönüyor, burada duruyor ama burada.
if you have any questions, I am happy to answer. Thank you.
Karşı yol.
Okay, yes, go ahead. Thank you.
What must material science engineering do to take approval from your Turkish aerospace, especially from your department?
I didn't quite get the question.
What must material science engineering do to take
Good job.
approval from Turkish aerospace?
Okay. So you have to have a good team.
Sorry, especially government.
So my department, okay, so when I take resumes from like different colleges, different like from different so the resume comes through a good GPA mostly. So if it has a good GPA, we kind of like take that into account to like say that it's a good candidate, which can be employed within our department. But when I do like personal interviews, like one-on-one interviews with like our candidates, I want to see that the candidate should be enthusiastic about the work, what needs to be done there. Some kind of like trial or like say like understanding of like the research task and responsibilities and dedicated to like complete the work. So in our culture that I've seen like people are in the beginning like very enthusiastic about like things coming out. But we have some problems like getting to the end. So I want to see that like the guy or the person is dedicated enough or enthusiastic enough to see the final outcome of the work. But the company says that like the GPA is a criteria, the college is a criteria like overall the academic performance. But we can kind of circumvent like those issues if the candidate is good enough for us to be close. Thank you.
You have a question? Thank you. Thank you for the presentation.
Okay, the next speaker is Dr. Halil Ibrahim Ünal. The topic of the presentation is Green Deal and Sustainable Development. Halil Hocam.
Good morning, everybody. We may start the slide, please. This morning I will talk you sustainable development and the Green Deal and the green chemistry or green engineering to run the factories and product, especially the chemicals from chemical processes. Okay. Is it possible to produce safe chemicals and safe products by keeping the development as well in a country? There are so many environmental problems we know that in the world, such as increasing carbon dioxide ratio in the atmosphere due to the factories and melting glaciers, rising sea level, increasing forests, fires, decreasing size of the lakes and long arid periods, drought in rivers, increasing temperatures in winter seasons, early spring, erosion, and so many other problems. We are aware and we are facing these problems in the environment. So what shall I do? Slide oynatır mısınız lütfen?
Hocam bir deneyebilir misiniz?
Yeah, okay, thank you. So there's a prevention of pollution law. It says prevent or reduce the pollution, recycle, use alternative resources, prevent the release of waste to the environment, and Kyoto Protocol and Green Deal, Paris Agreement, both are assigned by the Turkish Parliament. So what is green chemistry then? It is the studies to reduce or eliminate the negative effect of chemicals or chemical processes in the environment, on people and on other living things. It's a multidisciplinary movement to find a solution to existing and emerging problems. So sustainable development is desired by the governments, and economy runs on the sustainable development, and science is on the run, and also green chemistry is the intersection of these development and science. So green engineering is the design, commercialization and use of processes and products which are feasible and economical while minimizing generation of pollution at the source and minimizing the risks on human and the environment. So what is sustainable development then? According to the United Nations, the sustainable development can be defined as providing for human needs without compromising the ability of future generations to meet their needs. So the United Nations ruled out that there are a few principles for the sustainable development. One of them is visioning, other one networking, truth-telling, learning, and loving. So these are all under the control of scientists and some of them under the control of politicians. So what does Paris Green Deal Agreement say? They are focused on the green production of products and not using fuels-based chemicals, and they are targeted to reduce the greenhouse gases by 2050 and transportation, taxation policies and reducing greenhouse gases by 55% up to 2030 when compared to the 1990 levels. So they have a budget of 1.8 trillion euro to meet these conversations. So what are the benefits of European Green Deal? The European Green Deal will improve the well-being and health of citizens and future generations by providing fresh air, clean water, healthy soil and biodiversity, renovated energy-efficient buildings, healthy and affordable food, more public transport use, cleaner energy and cutting-edge clean technological innovations, longer-lasting products that can be repaired, recycled, and reused. We call this 3R, and future-proof jobs, and globally competitive and resilient industry are the benefits. So sustainable development has three legs. One of them is social sustainability, other one economical, and other one the environmental sustainability. We are going to focus on the environmental part, which by using the renewable energy sources efficiently and by being responsible to the nature. So both green engineering and green chemistry work for the sustainability by considering the Green Deal. So there should be some collaborations to run these green chemistry, green engineering, and sustainability both. Scientific organizations there should be, such as industrial, national research, business, national lab, environmental groups, international organizations, but they should get support from public, government, and academia as well. So is there any pressures on the environment? Yes, limited fossil fuel resources, effect of rapid development on the ecosystem, effect of population growth on the ecosystem and the natural resources, and non-sustainable wild industrialization are the problems. So what can we do? We can assess the readily available running production system by starting from starting materials, reagents, products, byproducts, solvents, reaction conditions, efficiency, and yield of a reaction, etc. And we can identify the hazards of efficiency of the running system, and we can modify the process according to the green chemistry rules and test the efficacy of the new process. If it's okay, go ahead. If it is not, and go to the plan B and run another process in accordance with the Green Deal. So what does the Green Deal say? They say reduce waste, reduce materials used, reduce toxicity of the materials and outcome of the process, reduce hazards, reduce energy use, reduce environmental factors, and reduce cost of the product materials. So to do this, there are so many tools we can use in the green chemistry and green engineering. I will give you a few examples on these processes. You can have a look at on these. And these are collected under the principles of green chemistry and green engineering. Prevent waste, design safer chemicals, reduce hazardous chemicals, use renewable feedstocks, use catalysts, avoid chemical derivatives and byproducts, apply atomic economy, use safer solvents and reagents, increase energy efficiency, design chemicals and products to degrade after use, analyze in real time to prevent pollution, and finally minimize the potential for accidents at the work. Now let's look at these one by one, and I will give you one or two examples on each. The first one is prevent waste during the production of chemicals. So what wastes come from final products? Residue reagent. These are all dangers in plastic materials, and residue solvents, use of surfactants and additives, and undesired byproducts. Some of these stay in the final product. So, is there a possibility to remove these residues from the final product? Yes, there are some chemical methods and some physical methods. We can discuss these if you wish after the speech. So how we can prevent waste? Instead of using petroleum-based starting materials, we can start from the renewable resources to produce the final product, or we can use industrial waste. This is sulfur, residue of petroleum products, and other one, carbon dioxide, residue of so many factories. And by using these sulfur and carbon dioxide, we can produce value-added polysulfide materials and use these polysulfides as whole transport material for dye-sensitized solar cells, cathode material for power storage, photocatalyst for water splitting, and heavy metal capture for environmental remediation. For example, for this one, I have another slide. We can prepare membrane films from polysulfides to capture residue mercury, or we can produce fibers from polysulfides to capture again metallic mercury. Second one is the designing safer chemical. What can we do? We can stay away from the components causing toxicity in the materials by using non-toxic solvents and non-toxic fillers. So these are the common solvents used in the industry now at the moment, but instead of these, we can use monoterpenes, which are the outcome of wood industry, or we can use ionic liquids, which we are working currently on these ionic liquids, or we can use supercritical fluids. For example, carbon dioxide is can be used as a supercritical fluid, and I will show you how we can use carbon dioxide. There are functional fillers, classical ones in here. Instead of these, we can use natural fibers as cellulose, etc., or starch, or pine wood floor, natural wood fiber, sugar cane, cellulose fibers, biofibers, and nano size of all of these materials are green materials, can be used as a filler. Other one is refuse hazardous chemicals used in processes. So what can we do? We can design synthesis to use and generate substances with little or no toxicity to the environment. These are the bio-based materials, cellulose derivatives, polylactic acid, biodegradable polycarbonate. These are safe materials, can be used in any plastics industry. These are used as stir, drug delivery systems, implant applications, and tissue engineering applications safely. What we can do again, we can use bio-based reagents. They are environmentally benign monomers via catalytic reduction of starch, and monomers can be obtained via biocell production, starting from glycerol and producing polyglycerol, or starting from polyols to produce polyurethane by using a isocyanate initiator material. So it has been reported in the literature that the performance of these polymers is similar to or even superior to fossil fuel-based polymers. Okay, for example, we use so many surfactants to produce materials in the industry. Instead of petroleum-based surfactants, we can use bio-based surfactants. This surfactant molecule is bio-based surfactant. This is used during the production of polystyrene beads. And this is surfactant used. These are polystyrene beads. And this is another sodium sulfate, and this is other surfactant used. So it is good. So flame retardants are also widely used in the industry, in thermoset and thermoplastic materials especially. So instead of halogen containing or phosphorus containing fire retardants, we can use tartaric acid. It is safe. It is the byproduct of wine industry. Is there any possibility to use biological catalysts and reagents? Yes. Instead of using petroleum feedstock to produce gallic acid and trimethoprim or vanillin, we can start from natural cellulose to get the same kind of products. Other rule is use renewable feedstock. Material synthesis with renewable reagents are attractive because of their high energy, heteroatom functionality, natural abundance, and low cost. And these reagents are classified as vegetable oils, lignin fragments, sugars, rosins, glycerols, purans, tannins, tuberins, terpenes, and others like citric acid, tartaric acid, and carbon dioxide. Let's look at carbon dioxide in its more detail. It is waste. and released to the atmosphere, and we don't want it. There are so many millions of tons of carbon dioxide are released every year to the atmosphere. So what can we do? We can use this carbon dioxide as a starting material to produce polymers. In this one and also in this reaction, we can use carbon dioxide as a starting materials, and we can increase the number of examples. Other use is we can use supercritical carbon dioxide as a dry cleaning liquid instead of this perchloroethylene organic molecule, which is the product of crude oil. Instead of crude oil, use supercritical carbon dioxide. It is safe. To get supercritical carbon dioxide, you have to have the conditions of critical pressure and critical temperature above. Other one is use catalysts. We know that catalysts find a less energetic route, take the reagents to the products. So during this process, waste is minimized, energy consumption is minimized. This is almost one of the first catalysts used during the production of linear polyethylene. It is called Ziegler-Natta catalyst. Instead of this, we can use enzymatic catalysts. They are environmentally friendly, provide faster reaction rates, and perform efficient reactions at mild conditions, less energetic, and they provide selectivities during the production of polymers. For example, polyphenols, polyanions, vinyl polymers, saccharides, polyesters can be polycarbonates can be used by using these enzymatic catalysts. Other rule is avoid chemical derivatives and byproducts. In the industry, we know that while producing the main product, we get so many side products, and we don't want these. So can we prevent the production of side product? In chemical synthesis, to produce the main product, we sometimes use blocking method or using protecting groups or blockers, or use temporary modification of the reactants, which are money consuming, time consuming, and energy consuming. We can leave all these behind by following a green route. This is typical modification reaction to produce this polymer. It has some drawbacks. If we use protecting groups, we have to use more reagent, more waste, and renewable chemical process control problem. If we don't use protecting groups but remove protecting groups, final product can be porous. We may not want it, and it is not a widespread method. So what can be done? We can use solvent mixture, for example. During the production of this polymer, polyhema, we can use 50% methanol and 50% water to get the same kind of product. So it is almost water-based. Another rule is apply atom economy. You must remember the Lavoisier's law, conservation of mass. Number of moles of reactants should be equal to the number of moles of products at the end of the production. It is not possible in most of the cases. That's why you calculate yield percent of the process. What is it? It is 90% yield, perfect. So what happened to the 10%? 10% is wasted. So we can calculate this. we can design synthesis to prepare the final product containing the maximum proportion of the starting materials, the conservation of mass flow by Lavoisier. There should be a few wasted atoms. And we have two equations. One of them is called atom economy. It is the molecular weight of the desired product. For example, PET, molar mass of the PET, but it has a side product as well in two processes. In one of the processes, water is the side product. In other one, methanol is the side product. So for the denominator part, we add the molar mass of PET plus water, or molar mass of PET plus methanol. So we expect this one less than 100%, but we try to reach to the 100%. Another equation is called E factor. It is the weight of mass, for example, water or methanol in PET production, divided by the total, so divided by the product mass. We want this one to be 0 and this one to be 100%. And I will give you an example. For example, during the production of nylon 6,6, we start from these two materials, starting reagents, and we get nylon 6,6 plus water as a side product. We don't want this. So it reduces atomic efficiency to 91%, and the E factor is 0.079. In the production of this polyurethane, we have two reagents. This is safe, this is dangerous due to the isocyanate groups. Atom efficiency is 100%, there is no side product. And E factor is 0. It is in accordance with the Lavoisier's rule. Let's look at the production of PET, for example. There are two routes for the production of PET. One of them produces methanol as a side product at Sasa. Other one produces water as a side product. That's why E factor is not 0, not like polyurethane products. Okay, other rule is use safer solvents and reagents. These are the organic solvents, dangers. They have volatility, flammability, explosion danger, flashpoint danger, toxicity, ozone depletion, storage, handling, and disposal difficulties of the organic solvents. Instead of these, we can use green solvents. They have advantages like low toxicity, low environmental hazards, low volatility, and recovery possibilities. What are the green solvents? Monoterpenes, wood-based, ionic liquids, supercritical carbon dioxide, biodiesel, and no solvent. And this is the phase diagram of carbon dioxide. I put it in here. So if you are above 31 degrees Celsius and above 73 atmosphere, you are at the critical region. So it is cheap, non-toxic, liquid-like densities, changes in the solvent densities, it's small changes in temperature or pressure, gas-like diffusivity, and a good solvent for small molecules. Instead of fuel-based initiators, we can use vegetable oil-based ester to produce methyl esters, which is used as biodiesel. It is environmental friendly, low volatility, low viscosity, and high boiling point. Okay. Another rule is increase energy efficiency of a system. We can run chemical reactions at ambient temperature and pressure whenever possible, because high temperature and high pressure is money. And recent studies have focused on controlling the heat of chemical reactions and lowering the temperature during the exothermic reaction. So we can use the heat of the exothermic reaction to run the process again. And this is used in steel factories during the coking process of coal. Heat is released and that heat is kept and used for heating the water of the plant and energy consumption of the plant. Other one is design chemicals and products to degrade after use. This is important for especially for the plastics industry. We can design chemical products to break down into innocuous substances after use, so they do not accumulate in the environment. So these are the problematic materials. They do not decompose in nature. So what can we do? We can design biodegradable plastics and other chemicals by using natural sources. What we can do, we can synthesize biodegradable plastic materials, and by using bioenzymes, they will depolymerize or degrade into monomers, dimers, or oligomers, and then in the atmosphere, they will convert it to carbon dioxide, water, methane, or hydrogen sulfate under oxygen or non-oxygen conditions. And these are the biodegradable fossil-based monomers. At least we can use these in the production of plastic materials. There are standards can be followed during the production of biodegradable materials. And there are 3 rules, as I mentioned earlier: recovery, reuse or recycle, and regenerate. Now, European Union asked for these to the Turkish companies, follow these rules during the production of especially plastics, thermoplastic, thermosets, and plastic containing composite materials. For example, we can start with starch, go to glucose, go to sodium lactate, and then lactic acid, and then dilactate and polylactide. This is called PLA. The starting material is starch. It is safe. So PLA is safe plastic material. If we use PLA as a starting material and plastic bottle is produced, after 80 days, nothing is left. It is biodecomposed. This is decomposition of another thermoplastic material, and this is starch. It is cheap. It can be found in plants and granules and biodegradable material. Yes. To get rid of these disadvantages, we can use it as an ingredient of composite materials. Another one is analyze in real time to prevent the pollution. We can include in-process real-time monitoring and control during synthesis to minimize or eliminate the formation of byproducts. And they are low cost, easy to apply, and calibration and maintenance free. And these are the instruments. We can follow the reaction conditions simultaneously, but they should be in combination with the industry 4.0. Turkish industry is at the moment at the level of 2.5. The last one is to minimize the potential for accidents. You know that there are so many accidents at the factories, so we can prevent this. We can design chemicals and their forms safely. There are so many dangers of the chemicals used in the industry. You can read these. What are these? These are external risks arising from emission from regular use processes, external risks arising from technological disaster, risks of work accidents, such as in Barton, and risks of work-related diseases. By taking these dangers, we can calculate years of life loss per unit of product for the neighbors. These are the thermoplastic materials used in the industry, and these are the years of life lost of the neighbors. So it is possible to prevent the pollution in the industry by providing regular equipment maintenance and education of the workers and using biological-based raw materials instead of fossil fuel-based materials, and especially going on to the technology 4.0. These are the disasters of divinyl benzene in Scotland before the explosion. After the explosion, this is Fukushima explosion. This is Lebanon ammonium nitrate explosion. And so we can use plants to produce chemicals, but if they are biodecomposable monomers, we can produce polymers, and plastics, if they are decomposable, they go into the soil and regrow again, so we can follow this cycle. I would like to thank you, the organizing committee, for inviting me, and I'd like to thank you for listening. If you have any questions, I can take. Any questions on green chemistry, green deal, green job, green engine? No question? Okay, thank you.
Dördüncü sınıf bütçe ağırdan online yapacağız. Tamam. Bunun aslında en azından arayacağız. Çünkü 15 Hocam duymuyoruz. Dördüncü sunu, üçüncü sunu iptal edilmişti. Dördüncü sunu Lütfi hocamız 11-10 gece bağlanacaktı. Haber verildi mi ona da erken bağlanması için? O zaman şimdi bir ara verelim. 11-10 gece normal saatinde bağlanacaktır. 11-10 gece burada olmak üzere oturumu kapatıyorum. Teşekkürler katıldığınız için. Ses deneme, ses kontrol, ses deneme, ses kontrol, Gazi Üniversitesi Teknoloji Fakültesi, ses kontrol, ses deneme, ses kontrol. Ses kontrol, ses deneme, ses kontrol, Gazi Üniversitesi Teknoloji Fakültesi. Ses seviyeni nasıl acaba? İyi mi? Ses sorun mu? Şöyle tutsak. Bu şekilde. Tamam. Aldı.
Şuraya yazsana şöyle. Yani yaz. Boş ver. Açık olun. Ama neye tanımlamak yok. Ben şuna ilan etsin de benim için çalışıyor. Olmaz mı? Vallahi yapıyorum ben. Canlı yayın. Aa. Yes.
Çalgıcı ya.
Sen bana nasıl?
Kaç kişi var?
Canlı yayın.
Fotoğrafı çek fotoğrafı. Gerçek biraz. Evet Hüseyin. Bunu böyle yapalım. Dur bir dakika.
Şey sahne var. Özür dilerim.
Ben fotoğraf çektim.
Herkese merhaba. Konuşuyor 2 saattir. Tam konuşuyor. Yani etkinlik var sandım. Elime terapi roman tutuyorum çantayı için koşa koşa gelmedim ne oluyor? Konuşmam yok. Ama fikir ben vermek istiyorum.
Gel.
ya. Ne gibi çıktı o nasıl bir açı
Sen
ya?
sen çünkü birkaç tane daha
Bak ya. Çok güzel bir açı.
Herkese merhaba. Zoom'un sesi açık mı?
Sesim çok güzel.
Öğretmenim.
bir soruya baksana ya. Ya. Benim
Canlı
Ay,
Canlı yayında açayım.
Açık mısın?